Today we're going to go ahead and look at the distributive property. This is, I would say, probably the last really major thing of section 1.2, although we do have a couple of more days on it. So for our distributive property, this is 1.2c, aptly titled Distributive Property. And for the distributive property, essentially what this does is it changes a product to a sum. And it'd probably help if you could actually see the whole thing. Changes a product to a sum. And probably in hearing this, it doesn't really mean anything to you, so as always, let's look at some examples. This one, we're just pretty much getting right into the examples. Our first one is 3 parenthesis x plus 1 close parenthesis, and we need to use our distributive property. Now, if you are familiar with the word distribute, it might help. You might be able to see where this is going. So for this one, we have the 3 sitting outside of our parentheses, and we're going to distribute it through and eliminate our parentheses in the same step. So we distribute the 3 by multiplying it by everything that is inside of our parentheses. So we need to multiply the 3 times the x, and then the 3 times the 1. 3 times x is just 3x, and 3 times 1 is 3. So this becomes 3x plus 3. Everything that's inside of parentheses gets multiplied together. Notice that we are not combining the 3x or the 3 at the end because they are not like terms, which is what we learned about in our last lesson. For another example, example 2, this one's a little bit longer. We have negative 4 times x plus y minus 4. But the distribution process is identical. We're going to do exactly the same thing. We need to multiply this minus 4 by everything inside our parentheses here. So the minus 4 is the negative 4 is multiplied by the x, the y, and the negative 4. And once again, we need to do each of these multiplications individually. So down here, we have negative 4 times x. Much like 3 times x was just 3x, negative 4x is negative 4 times x is just negative 4x. It's the same thing for the y. It's a negative 4 times the y, so this is negative 4y. And finally, we need to actually think a little bit about negative 4 times negative 4. You need to get your multiplication table, take it out now, and check 4 times 4, which is 16. And since it is a negative times a negative, this is going to be a plus 16. Notice that when we multiplied by the negative number, the signs on everything in here flipped in our final answer. So what had been positive became negative, and what had been negative became positive. In our first example, when you multiply a positive number through, the signs on each of the terms that are inside our parentheses did not change. They were both positive at the end. So, to put this into words, what we're doing is when you have parentheses you distribute the number in front. And to be clear, distribute means multiply. This is always the case. When there's that number sitting in front like this one or this one, we are always multiplying it through. Now, we don't necessarily always need to distribute the number. On occasion, it will not be a number you're distributing at all. It might be a variable. That'll happen occasionally. I don't think we have any examples today or in the upcoming assignment, but that is something that you should be aware of. Every once in a while, we'll throw a curveball at you. Now, let's go ahead and take a look at example 3. Example 3 is when we're going to start to hit you with just about everything that we've learned so far. So this is a solving problem. We have 2 times 1 minus x, parenthesis, plus 3 equals negative 8. Well, we need to use our distributive property first. So we're going to go ahead and start by distributing our 2 into our parentheses. We can't do anything inside the parentheses because 1 and negative x are not like terms. So we just have to distribute this 2 through. Now, I'm hoping that all of you are able to say, well, I know 2 times 1. Anything times 1 is itself, so we have 2. And then we have 2 times negative x. Now, the negative x is a little bit trickier. We have to think about this. What is our coefficient on the negative x? Well, it's actually a 1. And because the coefficient on it is a 1, this is the same as 2 times negative 1. Positive times negative is negative. 2 times 1 is 2. And since there's the x, it's 2x. Then, outside of our parentheses, we had a plus 3, so that just comes down, and a minus 8 on the other side of the equal sign. Now, we're still ways away from solving this problem. We need to apply what we learned yesterday, which is combining like terms. You might want to take this opportunity to pause and see if you can figure out the terms that need to be combined. But they are 2 and 3. So, since the 2 and the 3 are both positive, neither has a negative sign on them, we need to add them together. So we still have our negative 2x. 2 plus 3 is 5, and it equals negative 8. Lastly, we have gotten this into being a 2-step equation, and now we need to solve the 2-step equation. So we first need to isolate our x term here, the negative 2x, and we can accomplish that by getting rid of this plus 5. And we can get rid of the plus 5 by doing our inverse operation, which is to subtract 5 from both sides. Now we still have our negative 2x on the left side here. But now we now have negative 8 minus 5. So when 2 negatives are combined like this, or a negative and then minus a number, we need to add them together. So this is essentially negative 8 minus, this is essentially 8 plus 5, which is 13. But since they're both negatives, our answer will also be negative. Be careful what you get when you're thinking about doing a problem like this for multiplication and division versus addition and subtraction, because they have different rules, which we went over in section 1.1. Now, we only have one step left, and it's to get our x term, or x here, just as an x. No longer a negative 2x, just an x. And anytime we have a number and a variable sitting next to each other, they are being multiplied together, which means our inverse operation is going to be division. So we divide both sides by a negative 2. Now, on our left side, we're just left with an x. And on our right side, we have negative 13 divided by negative 2. Now, negative 13 and negative 2 do not share any common factors, so we can't reduce the fraction at all, although it does equal 6.5. Notice that since this is a negative divided by a negative, our final answer is positive. Negative divided by negative, negative multiplied by negative gives us a positive number. So our answer is either 13 halves or 6.5, whichever you prefer. And that is solving a problem involving distribution, collecting like terms, or combining like terms, and doing inverse operations. So if we were to write down all the steps that we have used thus far, our first one was distribute, which is also known as multiplying, or multiply. Step 2 was combine like terms. And finally, our step 3 was inverse operations. Until x is alone. So that took 2 steps in this problem after we did our distribution and combining like terms. And once again, our inverse operations are negative, or subtract and addition, and multiplication, subtraction and addition, and multiplication and division. This is pretty much the game plan for everything we're going to be doing in Chapter 1. Distribute, combine like terms, inverse operations until x is alone. I think we'll have probably one more thing we'll have to learn, but that will come in another lesson. We're going to go ahead and look at just one more example today. This one will be similar to example 3, and it would probably not be a bad idea for you to go ahead and pause the video and make an attempt on it yourself before I go ahead and solve it. So, example 4 here is the following. 5x minus 1 times 3x minus 2 equals 12. So in this one, we need to begin by doing our distribution. That was the step that we established earlier. We need to distribute first. So we need to distribute this thing, which is attached to our parentheses, to what we have inside of our parentheses. Don't forget to distribute the negative sign attached to the 1. That is very, very important. We must distribute the negative sign on its own. Once we do this distribution, another important thing to remember is that our 5x just comes down. Our 5x doesn't have anything to do with the negative 1 it doesn't have anything to do with the negative 1 in the parentheses, so it just comes down to the next line. Negative 1 times 3x, all it does is change the sign on our 3x, and negative 1 times negative 2 also just changes the sign on 2. One thing I really want to mention on this particular problem, and it's something that can really throw a monkey wrench in this if you aren't already familiar with it, is you very easily could have just written this part right here. I'll do this in purple off to the side. You very easily could have written this part right here simply as negative 3x minus 2. This and this are the same. That negative sign can be distributed just like a negative 1, like we did here. And that's something you're going to want to watch out for, because just having a negative sign here and distributing it in parentheses will be a common skill you'll need to utilize. Now, from here, we need to go ahead and combine our like terms again, which end up being these x terms here. 5x minus 3x is basically just 5 minus 3, which gives us 2x. We still have our plus 2, and we have a 12 over here. Next, we need to go ahead and carry out our inverse operations. Now, we first need to get our x term here alone, and we have a plus 2 here. So we need to do the inverse of adding 2, which is subtracting it. And that gets us to 2x equals 10, as that is 12 minus 2, excuse me. Finally, just like the previous problem, we're now sitting with the 2x. We need to just make it an x, so we need to divide away the 2 we have multiplying by the x here. And once we divide 5 by 2, you might need to check your multiplication table. We end up with an x equals 5. If you're not sure if this works, you can go ahead and plug it back into the original equation and confirm that it does end up coming out with a true statement. So that covers the distributive property, and we've covered a significant amount of the algebra skills you're going to be needing for the rest of the year. So make sure you finish these assignments that are associated with this, because they are important in reinforcing the skills.